Hello students, today we discuss matrix, rank and null space. So first we look what is matrix and some special type of matrices. So definition of a matrix is a set of mn numbers, real or maybe imaginary, arranged in the form of rectangular array of m rows and n column is called a m cross n matrix, and it is denoted by a capital letter A is equals to Aij m cross n, where Aij represents the element of matrix. Here m cross n represents number of rows and number of columns. These rectangular array might be constructed by some coefficient of system of equations, and it matrix helps us to solve system of equation in an easy way. So now we look with some special type of matrices. First, row matrix, in which we have number of rows are 1, that is m is 1 and n might be 1, 2 or 3. So row matrix is a matrix of 1 cross n type matrix, whereas column matrix is in this matrix we have one column, that is it is of the type of m cross 1 type. Null matrix, a matrix whose all elements are 0. A square matrix, if number of rows and number of columns are same in a matrix, then it is said to be square matrix. And after that we have a diagonal matrix, a square matrix in which at least one element of diagonal entry is 0, and except those all are 0. Then such type of matrix is known as diagonal matrix. Scalar matrix, if all the elements of a diagonal matrix are same and non-zero, then it is called scalar matrix. Identity matrix, special kind of scalar matrix in which all the element of diagonal elements are 1 only. That is unit element. After that we have upper triangular matrix. Upper triangular matrix, so we have a square matrix. We have a square matrix, and in upper triangular matrix the element below diagonal are all are 0, and at least one element above diagonal must be non-zero. And in case of lower triangular matrix, all the elements of above the diagonal are 0, whereas at least one element below diagonal elements are non-zero. So mathematically it can be written as Aij is equals to 0 for upper triangular matrix. Aij are the elements of matrix. Aij are 0. I represent the ith row, j represent the jth column. For I greater than j, for all I greater than j, if Aij are 0, then we say it's upper triangular matrix. And in lower triangular matrix, Aij will be 0 for all I less than j. Number ith row must be less than jth column. In that case, if Aij, all Aij are 0, then we say it's lower triangular matrix. And these are not useful this time. Now rank of matrix. Now what is the rank of matrix? A number R is said to be the rank of matrix A. A could be any matrix of m cross n type, need not be a square matrix. Number of rows and number of columns might be distinct. A number R is said to be the rank of matrix A if it possesses following two properties. First one, there exists one square submatrix. There exists at least one square submatrix of order R whose determinant is non-zero. We can divide given m cross n matrix into some sub-square matrices whose order is less than m cross n. So, but the submatrix should be square matrix so that we can calculate its determinant. And we have a subsquare matrix of order R whose determinant is non-zero, and whereas second property says if the matrix A contains any square submatrix of order R plus 1, means all order greater than this R, then the determinant of every square submatrices of A of order R plus 1 or higher should be 0. It means determinant of all the subsquare matrices whose order greater than R must be 0. In that case, rank of matrix will be R. So, what is the rank of a matrix? Rank of a matrix is a number R. This is simply integer or natural number. It might be 0, it might be 1, 2, or if the order of matrix is m cross n, then maximum possible rank of matrix is minimum of m comma n. So R is a number, is a rank of matrix if R if given matrix satisfy two property. First is it contains at least one subsquare matrix of order R whose determinant is non-zero, and all the subsquare matrices whose order greater than R must have determinant 0. In that case, R will be rank. The rank of non-zero matrix is either greater than always greater than equals to 1 or less than equals to minimum of m cross m comma n. The rank of matrix will be R if the given matrix is null matrix. Otherwise, no matrix have rank 0. No matrix which is any matrix which is not a null matrix never have rank as 0. So now we'll look some problem based on rank, and before that first we look what is elementary transformation, because we use these such transformation to calculate rank of given matrix. So first elementary transformation is Ri interchange with Rj. It means any ith row can be interchanged with Rj. We have suppose we have a matrix A. Its first row is R1, second row is R2, third row is R3. So when we interchange, suppose two rows, suppose R1 and R3 we interchange. So first row become R3, second row remain as it is, third row become R1. This resultant matrix will be same as previous matrix A. So after using elementary transformation, in basic properties of matrices couldn't change. So first elementary transformation is Ri interchange with Rj. Second second elementary transformation is Ri can be replaced with k times Ri. Here k is non-zero scalar quantity. It might be rational, it might be integer, or if required it might be rational. So any row can be replaced with k time itself, but k must be non-zero. And third elementary transformation is addition of k time. K is again non-zero scalar. Addition of k times jth row to the ith row, that is Ri can be replaced with Ri plus k time Rj. So using these three elementary transformation, we will calculate rank. So here we have a problem. Find the rank of given matrix. We have a 4 cross 4 matrix. Its row wise elements are 0 1 minus 3 minus 1, 1 0 1 1, 3 1 0 2, and 1 1 minus 2 0. So we have to find its rank. Its minimum possible rank will be 1 and maximum possible rank will be 4. It means its rank lie between 1 and 4. It might be 1, 2, 3 or 4. So before calculating its rank, first we have to convert it into echelon form. So what is echelon form? In echelon form, we try to convert this element, lower corner element, into 0. And after that we try to convert this element into 0. Further convert it into this element into 0. When we have converted all these elements into 0, now we try to convert this second element, the last element of second column, convert into 0. But one thing should we remember, that all the element which we have already converted into 0 must retain as 0. Means when we convert next element into 0, previous converted 0 must retain as it is. So keeping this point in mind, we try to convert, using elementary transformation, we try to convert this matrix into echelon form. So first we use elementary transformation R1 interchange by R2, so that here we can create non-zero number. So when we convert, when we use elementary transformation R1 interchange with R2, we get this matrix: 1 0 1 1 0 1 minus 3 minus 1, and third and fourth row remain as it is. There is nothing change in third and fourth row. Now to convert these elements into 0, we use first row. With the help of first row, we will convert this element into 0. And how? So that so we use elementary transformation to changes into fourth row. We use elementary transformation. R4 should be replaced with R4 minus R1. That is, here we use third elementary transformation. Ri can be replaced with Ri plus k times Rj. Here k is minus 1. So here we have 1, here we have 1. To convert this 1 into 0, what we will do? We will subtract same amount. So here we have 1, so we subtract R1 from R4. Now to convert here 3 into 0, what we will do? We will subtract 3 times of R1 row from R third row. So R3 minus 3R1 will give us 0 here. So but in that case, nothing change will be happen in R1 row and R2 row. So when we apply these two transformation, in third row become 0 1 minus 3 minus 1, and fourth row become 0 1 minus 3 minus 1. Now we will convert this element into 0, and keeping the fact in mind, these converted 0 must retain as it is. So to convert this element into 0, we can use say third row, or we can use second row. Same, after converting this 1 into 0, we will convert this 1 into 0. So with the help of second row, same time we can convert this element into 0, and same time we convert this element into 0. So we use elementary transformation. R4 should be replaced with R4 minus R2, and R3 replaced with R3 minus R2. So it converts into third and fourth row complete become 0, and first row is 1 0 1 1, second row is 0 1 minus 3 minus 1. This resultant form is known as echelon form of given matrix. Number of non-zero rows in an echelon form, in resultant or converted echelon form, is the rank of given matrix. Here number of non-zero rows are 2 only. That's why rank of given matrix is 2. Now we can convert it into normal form. To convert it into normal form, we will convert these all element into 0 form. That is, only leading element remain as 1, and except the leading element of each row will be 0. Such type of form is called normal form. Here the first non-zero element is known as leading element. That is, in first row this element is leading element, and in second row this element is a leading element. So except these two leading element, all element must be 0. Now to convert these element into 0, we will use column transformation. So we use C4 replace with C4 plus C2, and C3 replace with C3 plus 3C2. We get this form. Now still there are two elements which are non-zero. So to convert them into 0, we will use C3 replace with C3 minus C1 and C4 replace with C4 minus C1. Hence we get 1 0 0 0 0 1 0 0 and the last two rows are completely 0, or it can be written as I2 0 0. Here number of non-zero row again 2, and it's I2 identity matrix of 2 by 2 order, so rank of this matrix will be 2. So these are the method to find rank of given matrix. We can find the rank of given matrix by converting it into echelon form, or after that we can also convert echelon form into normal form. So that's all about how to calculate rank. Thank you.